Solve Leetcode question 146 LRU cache, and it's a median Leetcode question. So basically design a data structure that follows the constraints of a least recently used LRU cache, implement the cache class, and the capacity, initialize the cache with positive size capacity, and you will implement the get, return the value of the key. If the key exists, otherwise return -1. Put and int value, update the value of the key if the key exists, otherwise add the key value pair to the cache. If number of keys exceeded the capacity from the operation, evict the least recently used key. The function get and put must each run in O1 average time complexity. And here is the example here. And you have a least used cache with a capacity of 2. So you can only put 2 key and value pair here. And then when you put one key is 1, value is 1. And then the next one is put, and then you put 2, 2, and then you get, when you get 1, that is 1, right? And the next one is put, you put 3, and you get 2. And when you put 4, and then you get, the next one is 1, and then get, and then get, right? So this is the output that you're expecting. When you put, you're not expecting any output, but when you get, you will get the output 1 and -1. So you have to consider some of the cases it mentioned to you that when you put in the capacity, it's initially is 2, right? And then you put value 1, like this example here, and you put 1 there, and you put 2 there, and then when you get cache 1 is 1, right? And then when you put 3, and it has 2, the cache has 2 value, it needs to evict the key 2 because the 1 was just the one that accessed. So then you want to pop, like remove the least used one, so that you can put in 3. So then the cache has 1 and 3. And then if you want to get 2, return -1 because 2 is not found already. And then when you try to put in 4, the key was 1, evict the key 1. So the cache has 4 and 3. And then because 3 was just put in there, it was most recently accessed. And then when you try to get the 1, it does not exist already because it exceeded a capacity. So you only have 3 and 4 left, and you don't have 1 anymore. So it's at -1 not found. And then when you try to get 3, it returns 3. When you try to get 4, it returns 4. Here are some constraints here, and here the company asked this question in the last 6 months. Insane amount. I would say this question, you must know how to do it. And if you want to do this, most easy way is Python has a data structure called ordered direct, but you probably won't be able to do this in interview, and they might ask you to implement everything manually so that you can they can see how you understand different data structures. And then the best way to do this is actually you use a hash map, and hash map plus a double linked list. And the reason that you're using double linked list is you can easily delete and add node with delete node within O1 time complexity according to the requirement. And if I show you how to do this, you will know this better. And basically, let's say if you have a hash map here, and your hash map has a key value pair, and initially your capacity is 2, right? So you only max allowed to put 2 items in there, and then you initially put key is 1, and then value is 1 as well, right? And then you put in 2 and a value as 2 as well, right? And then the for the key, and then you can actually put the key value pair and this into linked list and make sure 1 and 2 are doubly linked list, and like this 1.2, 2 and 2.21 basically 2 is also 0.21, something like this. So then you want to continue to add the node, and when you try to get one, because there are double linked lists, when you try to get one, and it will return 1, right? And then because you just get one is most used, and then you want to make sure that the most used one always get to move to the head, so then you know that this is just most recently accessed, and then you want to when you put 3, you will remove 2 because 2 is the least used. So I'll show you how to do this in code, and you will understand better. And in order to do this, we need to define our class node class for the linked list so that you can easily do this. And so when you define the node, and it's the same thing in it, and then I'm just gonna put our self here so that we can reference it, and self.key equals to 0 at the beginning, and value equals to 0 at the beginning too. And for this node class, I want to also define the previous node, and I'm gonna set it to no at the beginning, and the next node I'm gonna set it to no too. So this is the LRU class, right? Initialize it. And I'm not going to initialize it yet. I'm going to, or we could initialize it. And let me just type the initialization first, and that's totally fine. So I'm going to say user cache, and I'm going to define this cache as the hash map that I mentioned to you so that I can store different key and the value pair here. And the self and size is important to decide, and I'm going to put set size at 0 at the beginning. Capacity equals to capacity that they defined for us, basically is 2 in this case, and self.head. I'm going to define the, since I already defined the node class, right? And I'm gonna set the node self.head, and I'm also gonna set a tail. Just we'll use the tail. When we pop from the list, you will see that we will need a tail pointer, and I define a node and a self head dot next. I'm gonna set head dot next to self dot tail right now, and self dot tail dot prev is equal to self dot head. So they're doubly linked list right now. It looks like head pointing to so right now it looks like head pointing to tail, and the tail is also pointing to head. So they're double listed. And I'm gonna need a few different functions, and I'm gonna create a function to add node to this cache first, and I'm gonna say add node. This add node is I'm gonna try to add node self and node. I'm gonna try to add the node right after tail. Or right after head, sorry. Like the reason that I wanted to do that is because I want to make sure that I always put the just accessed one right after head, so I won't delete that, if that makes sense. So when I do that, if you think about it, how do I add a node? If I have a head node and I also have our next node, let's say something like this, right? And And if originally it was these two nodes, right? If I'm trying to add another node in between, what I need to do is not only need to pointing the head to the node and node to the node, and I need to add a double direction, include them into the list, right? Basically, this is how you do it. So node.pref is self.head. So I have to set the node's previous node to head and node's next node to self.next, right? Node.next is self.head.next. And then I'm gonna say that's the other direction, self.head.next.pref. Self.head.node.pref originally pointing to the node that their pref node is now the new node that I just added right after the head, and the self.head.next is equal to node. Yeah, if you look at the picture and you can see there, basically originally you break the original link between them and add it into these four added node into the existing one. And then I'm gonna also define another function, remove node. That's when how you remove node between a two node that you already have. Let's say you try to remove the node between the basically the pref and the new node. So I'm gonna say the pref equals to node.pref, right? And then new equals to node.next. So the picture, if you look at it, it will be like pref is linked to node, node is linked to new. And then if you want to delete this node, they're double linked list, right? So you want to just need to set a two pointer. Pref's next, you just need to set it directly to no, and new's pref, and you just set it to pref. So in this way, you already removed the node in between the pref and the new. So you already did this. And then I'm going to say every time when I access a node, right, I'm going to move the node to head. So I'm going to define this function, say move to head, and I'm going to say self and do a node. And how I do it is self. I basically remove node from the list, and after I remove the node, right, I'm gonna add the node back to the list. It's because when I add the node, I always add it right after the head. So that's why this function, what it achieves is remove to head. And then I'm going to define another function called pop tail. So it's basically self. And when I pop the tail, just basically pop the tail from the list. Basically result is equal to self.tail.pref, right? And then I'm going to self call the remove node function and remove the result. And then in the end, I'm going to return the result. So I pop the tail in this case, and we have already defined the cache. And then now I'm going to work on the get. When I try to get a value, right? So the node is equal to self.cache. Cache is what we defined to get the key, and I'm going to set it to no first. And then if node does not exist, I want to return -1 in this case, that according to the requirement, right? If node does not exist. And then I'm going to, if node exists, I'm going to move to head. I'm going to move it to head because I just accessed this node, and I'm going to return the node.value. That's the node that we want to try to get from the hash map here. And then the next one is put. How do I add a value? So the node equals to self.cache dot get and basically the key, right? And if node does not exist, so I'm gonna say the new node, and I'm gonna define this new node first, and new node key is equal to key, and this new node dot value is equal to value. And then I'm gonna say the key in the cache is equals to the new node that we just defined, and self, I'm gonna call the add node function. I'm gonna add this new node, right? And then I'm gonna add the size, increase the size because I added one new node. Now I'm gonna check that condition check if the self size is bigger than self.capacity. If it exceeded the capacity, I have to remove node. But when I remove the node, I'm gonna pop the least use, the least access, which is at the tail. That's why the pop tail function come handy. So I'm gonna call the pop tail function. So I'm popping the tail already, and then I'm gonna delete the self cache, and I'm gonna delete the tail dot key. I'm gonna delete the tail, right? Delete the tail, and after that the size has decreased to 1. So I'm gonna size -1. If the node is already exists, right, and I don't need to do all these things, then I just change the node dot value to value, update the node dot val with the node value. And because I just accessed it, I always have to remember to move this node to the head, so that it's just accessed. Next time when you delete anything, it will not get deleted. I hope this is helpful. If you think this is good, please like my video and subscribe to my channel, and I'll see you soon with more Leetcode questions. Bye bye.